People say they like OBS. Oh, okay. I like OBS now. I can hear myself.
All right, I'm posting
Wait,
it live.
all right, good. I need to confirm because I don't want to do a recording where I can't hear myself. All right, awesome. So, I guess we'll start understanding Bitcoin Source 19. Actually, I had a application where I can look at the chat on Twitch. It's called Chatterino, and unfortunately, it said failed to load. Actually, can I? Hello. It doesn't matter. I think I could view through here. Anyway, yeah, understanding Bitcoin Source 19. So today we will be going over what fees and fee rates are and why we have them, how a fee rate is calculated for a transaction, how Bitcoin nodes determine acceptable fee rates for mempool eligibility, and how the selection of UTXOs play into fee calculation, as well as some challenges and leading algorithms for coin control, which again I've gone over before. In fact, I have two presentations. This is from the first one. Nope, this is from the second one. This was from the first one. And the diagrams I had weren't very helpful for people. That's why I made the second one, but I'll defer here. Hey, how's it going? We could have helped, but. Oh. Yeah, so I had this whole introduction about how much energy it took to break a block. Um, it's kind of interesting, but I've done it before. And the last one is all napkin math. And it was about how the energy needed to solve a block is nearing the energy set off by Hiroshima was the idea for it. And I thought it was a kind of a cool conceptual thing to think about, that all the energy we use for bombs could be used for mining stuff.
Wait, so it takes how many Hiroshimas to do a block?
I was nearing one Hiroshima.
Okay.
Yeah.
Anywhere approximately.
Right. Yeah.
Hiroshima.
Yeah. Hiroshima has a lot of energy, so it's yeah. We don't have multiple Hiroshimas in a block yet, but as things progress, in the future, maybe we will.
Wow.
Then I had these prices. All of this is kind of outdated because it was in a different price range for Bitcoin. I don't know the price range at the time that I made this, but $315,000, 485 was, or $315,485 was the amount that it took to mine a block with my energy prices back when I first tried to do this presentation.
For your home, for your house?
Yeah.
Okay.
And it was very expensive, compared to what it would be in El Salvador, somewhere where energy's cheaper. I actually don't know if El Salvador energy's cheaper, but I imagine it would
Yeah,
be.
'cause they have that geothermal.
Yeah, or they're working on it. I don't know what they actually have already, their whole park project. Yeah, so the price of admission for a one input, two output SegWit transaction. I was trying to say, look at how much energy is securing your transaction. Can you guess how much a transaction fee would be for a one input, two output SegWit transaction?
I don't know.
No? Okay. Well, it was about, at the time, 85 cents, which is,
What fee rate?
it was a higher fee rate environment. Even now it's like a lot cheaper. And fee rates are a question of what you as Bitcoiners are willing to pay for this type of security. So that's the intro that I'm speeding through, since it's only a 45-minute session today. And then I had this, which is how I started in that second presentation. Yeah, what is a transaction fee? Oh.
Sorry. This is distracting.
No, it's fine.
What is a
You know.
transaction fee? It's the market rate for
Block space, basically, right?
block space, yeah.
Yeah, I would say a market rate for block space makes sense. But you could also, it's a range, right? You could put a cheap fee and have your transaction get mined in a couple blocks down the line, or you could have an expensive fee and have it get mined right away or quickly. So I have this, a transaction fee is the difference between your input values and your output values in a transaction. So like fees are implicit within a transaction. They're not explicit. You don't put the exact fee that you want, and it's spendable by the miner who mines the transaction. Your transaction is contained within. So it actually doesn't need to be spent by the miner. The miner could, specify any address or script pub key of the transaction that they want the funds to go to. Usually it's the miner. But it could be, actually, I don't know if it's usually the miner. I think sometimes it goes to custody services. So miners actually mine to addresses from other companies sometimes. So why do we have fees? Any good answers for this one?
To block spam.
Yeah. Well, that could be a reason.
Yeah.
Yeah.
Spam is mine.
It's an incentive for producing blocks that's not dependent on the what do you call the new money?
Coinbase.
Hmm? The subsidy?
The subsidy. It's
Okay.
a non-subsidy based incentive for miners to continue producing blocks.
Yeah, it's a non-subsidy incentive. I like that. And I have some reason for fees here, which we have a maximum block size of roughly 4 megabytes. We have roughly 12,195 SegWit transactions per block maximum. And yeah, it's basically because there's scarcity in space, bandwidth, and block propagation time. But also because of that, subsidy problem where it's going to go down over time, and we're going to need these fees to pay the miners. But even if we had subsidies forever, fees are still a great way for prioritization in terms of transactions. If you want your transaction to go get mined first, then you're going to put a high fee on that. So yeah, reasons for scarcity: space, bandwidth, block propagation time. So those, good reasons why we have fees. I kind of boiled it down to scarcity, but the subsidy thing is also an important point. So can one transaction A get prioritized over another transaction B with a higher fee? Well, so this one was phrased a little bit weirdly when I first wrote it down, but is it possible for one transaction that pays 1 Bitcoin in fee to not get mined over another transaction that pays 1,000 sats?
Yeah, package relay, or packaging of multiple transactions together.
Yeah, it might be more profitable if there was let's say the one that had 1,000 sats had a child that was paying 2 Bitcoin, and it's going to get mined along with that child instead of that transaction B that has the higher fee. But we also have other things to consider, like the size of a transaction. So fee rates are something that's emphasized. If you have a huge transaction and a very small fee, absolute fee, then your fee rate is very low. And this idea of a fee rate is your fees with respect to the size of a transaction. So you can think of the fee rate just as the absolute fee that you have, which might be a Bitcoin, divided by the bytes of your transaction.
The weight.
Uh,
The weight.
Yeah, or the virtual size.
Virtual size.
Blocks have the weights, and then we have a virtual size for these transactions, which is computed, according to these weights that we assign for blocks. Yeah, fee rates are the number of satoshis you pay per byte or V byte of a transaction. So if it's a legacy transaction, you're paying for the byte. If it's a SegWit transaction, you're paying for something called like a V byte, which is a virtual size. You basically get a discount on certain bytes for SegWit transactions. That's why it's cheaper to spend with a SegWit wallet. And I have this transaction size calculator here of 1 input and 1 output transaction. Total V bytes is 10.5 for the metadata of the transaction, 68 V bytes for the inputs, which is 1, and 31 V bytes for the output. And this is for a pay-to-witness public key hash transaction. You can find this on Bitcoin Optech. It's kind of interesting to look at. So I had these diagrams, and I'm not gonna go because they confused everyone with it before. So here I'm gonna go to the revisited slides. Revisited. And here I have an alternative explanation. So you have something called the transaction confirm stats in Bitcoin Core. And it's the name of the class, which is a collection of related data and operations on that data in Bitcoin Core that manages and calculates fee rates. The first thing we do in transaction confirm stats is we make a lot of lists. And we'll keep track of 3 for now, because it's like a lot of lists, and it gets kind of confusing. So one is called conf average, another is called fail average, and the last one is called transaction count average. These abbreviations are used in the code, that's why I used it here. Conf average and fail average are fixed in size, which is 24 for default fee calculations, and each item in the list of conf average and fail average is a period. Now, each of the 24 periods consists of another list that we'll call buckets. So I don't know if hopefully you can visualize that, but it's almost like a 2-dimensional array or a 2-dimensional list where like you have a list of things and each item in that list has another list of things.
This is for the state of the whole chain to get the current fee rate?
Yeah, to get the current fee rate. You don't look at the whole chain when you like calculate the fee rate, but like you aggregate information as blocks come in. And there's like something called decay, where it like is supposed to naturally kind of decay the old calculations. But yeah, this is the thing that is used to look through every transaction and block and update itself to get the current fee rate. Yeah, it's gone. Buckets can be of any size and each contain a number initialized to 0. So I was going to show some code too, which might be less interesting for some. But this is the conf average. It is a vector, which is like this list. And this is saying that each item in this vector is another vector. So this is a list that comprise of lists for every element. And you have these comments from, Ben actually made some changes to this comment for whatever reason. And Alex Morkos is the guy who designed this fee system. But yeah, conf average, fail average are what we're going to look at. And just so you can see in the code, but let's go back. So yeah, you have, how's it going? So yeah, you have the list of conf average, fail average, and again, each item in that list is another list. And hopefully this is easy to conceptualize, maybe. So what do the periods mean? So you're free to like sit here. This chair's not that comfortable though. Yeah, what do the periods mean in the transaction conf average and the fail average list?
Are they different from like retargeting periods? What is that? 2-week difficulty adjustment period?
Yeah, with respect to the fee calculation, these periods are a little bit different.
Okay.
Yeah.
Then I have no idea.
Yeah. Any guesses? No. Well, the periods represent block periods. And transactions get put into periods based on how long they took to confirm. So in the conf average, again, in these lists, each list is a period. I mean, this is a list of lists. And in the list that's within each list item, well, these are called buckets, and the items in the first list are called periods. It's very like weird talking about 2-dimensional arrays, because from a programming perspective, it's kind of like somewhat intuitive sometimes, but like when looking at it and explaining it, it's not as easy. But
Is it, when you see, I've seen a lot of these fee rate charts that have the colored bands and to show how fee rates change over time.
yeah,
Just a wild guess, do those represent the same concept here?
I'm not sure. I'd have to see which one you're referring to. But yeah, again, to reiterate, we have a list of lists, and each item here is a period.
Is it the same as a bucket?
No, inside the period we have
Okay.
buckets. So then we have another list in here. and then this is a bucket. Does this visualization help? Maybe if I had some better indentation. Let's do this. Period. Again, this is my second time presenting just because the first time didn't go that great when I was trying to explain this.
I mean, you can just think of it as a table. Rows are periods mapping to the two dimensions here.
Yeah,
Rows are columns.
and then in each, well, sure, yeah, rows and columns.
So what's X here? Is it the actual, is it a transaction? Oh no, it's a double.
X?
It's
Okay, you can
Where's X?
like a conf average
first
in the
column.
comment, line 88.
Oh, in the comment?
Yeah, like, so it's like Y is the first a period and X is the bucket, but what's,
Oh, so these were made by Alex Morcos, the guy who designed the algorithm. So I don't really know why he chose X, and I mean, he defined it up here. Okay, each bucket X. Yes, you have your period, and then you have your bucket. So this is the period. So you have a list, and each item is a period, and within each period you have buckets, which is actually no, this is a bad one. Period. Yeah. This, the items in here, this is your bucket. So you'd have 0, like, well, really they're just all zeros here. Okay, that's a better visualization.
right?
Two-dimensional list. You have a list, and the top level item is the period, and the inner items are the buckets. All right, so periods represent block periods, and transactions get put into periods based on how long they took to confirm. The first period will process transactions that get confirmed within 2 blocks or less. The second period will be for transactions recorded in 4 blocks or less, and etc. The number of confirmations each of the 24 periods represent is called the scale in the code. So like each period is like represents a period of blocks, and the scale of the number of blocks that each period represents is like called the scale in the code. Each period contains buckets that represents an increasing like fee rate. So going back to here, like this is kind of implicit in the code, but like this would represent fee rate 1, and this would represent like fee rate 2 sats per vbyte, and so on and so forth. So this is like a count, actually. You're counting the transactions that are within the bound of 1 and 2 in this bucket. And this is for the period. So like for all transactions that are confirmed within 2 or less blocks, you will increment the correct bucket based off the fee rate of that transaction. Yeah? No? It's a weird structure. That's why like I don't know how to explain this better.
So, okay, tell me if this is a good explanation.
Yeah.
Each period represents a different weight, a different range of weights.
Well, each period themselves,
Sorry, by weight I mean this 1 sat per vbyte, 2 sats per vbyte, like what's the term?
okay, these are buckets, yeah. So like,
I mean that unit.
yeah, in the overall list, we have like,
It's a histogram.
histogram. Yes, within a period. But the problem is we have like multiple periods, and I think that's what complicates it. Actually, let's just flatten this down. We don't need this idea of periods. Let's just have idea of, we have 1 period, and within our period we have a list. This is just 1 list. And within this period list, we have buckets. And whenever a transaction is confirmed within less than 2 blocks, we'll increment the number of the bucket for which it belongs to according to its fee rate. But that a better way to explain it, just looking at a period?
So it's looking at when it came into the mempool and then how many blocks later it actually
Yeah.
confirmed?
But it's by time.
But block time. Yeah,
Right.
yeah.
Within 2 blocks.
Yeah, so we're only focusing on this one period. So this thing is one period.
Okay, so everything in here happened within the last 2 blocks?
Yeah.
Okay, and then the period that it lands on is based on how big of a
Well,
transaction?
we're only using one period. The bucket that it lands on.
So
Yeah,
all
it
the-
depends on the fee rate.
All the things within the period are in the same one block?
Within the same scale of blocks. See, when we have multiple periods, it's like complicated, but yeah, within a period represents like, oh, the transactions that we're counting in this thing happen like less than some block threshold.
Got it. Yeah.
So for this, it's like 2 blocks. Maybe I'll just erase the whole concept of period. We're tracking in a list transactions that are 1 sat per byte, 2 sats per byte, and another prerequisite for this is we're only tracking transactions that have been confirmed within 2 blocks after being in the mempool.
Is it always like linearly increasing, like it's always 1, 2, 3, 4, it's not like?
Oh, it's not actually 1, 2, 3, 4. I did this to simplify it further. In the code, it's actually like, it's in intervals of 5%. So let's see if I can find it.
Percentage.
Yeah.
So it actually looks at the entire block and tries to see a range? Or-
No, like these are set before it looks at the block at all. But you do it in like intervals of 5%. It's chosen for the, and there's like different fee rate. Like I have to really simplify this down just to look at like one small thing. But you have different transaction confirmed stats too. So you're crunching a whole bunch of numbers. It's just like it wasn't written in a way that was easy.
Just looking back a certain number of blocks, 2 in this case, right?
Yeah.
And all the transactions that happened within that range of time,
Uh-huh.
you're taking a percentage of them, or you're saying this percentage of them has this weight, and this percentage has this weight.
Yeah, I'm counting them in that way.
And you have like, there's 10 here, 20 here, 20
Exactly.
here.
Yeah, that's the
That's a
concept.
histogram
Yeah.
of weight of transactions. You're taking a histogram of the sizes of the transactions for a fixed amount of time. in
Yeah,
blocks.
perfect. Yeah. So each period is a histogram representing the transactions that are calculated or that have been confirmed within 2 blocks after going to the mempool.
And so if you do multiple periods, you're looking how the histogram changes over time.
Yes. Well, not really, because one transaction can get counted in 2 histograms. The second histogram is counting all transactions that confirm within like 4 blocks.
Okay.
Right? So like a transaction that was confirmed within the first block is going to go in both in the first histogram and the second histogram.
But you've got this decay factor, so their impact is lessened over time as time goes forward.
Yeah, in general, if your old results, they get
Until they get
reduced
confirmed,
with the
right? So they
decay.
drop out of the mempool.
Well, decay, all tracked items will be decayed eventually. If it drops out of the mempool, then that's considered like a failed transaction. And I didn't go into that because that's more to cover.
The main way for them to go out is to be confirmed.
Exactly. Most of the time, they will be confirmed. So yeah, first period, all right, I think I explained that as best as I could. The number of confirmations each of the 24 periods represents scale. First bucket, 1, next 2, all right. Recording transactions with transaction confirmed stats. So now that we have this structure, how do we record transactions? When a transaction gets confirmed, it gets added to the fee rate bucket in the period in which it was confirmed. So if it was confirmed within like a 2 block period of entering the mempool, then we will look at the fee rate bucket that it belongs in, and we'll increment it. So let's say we get one transaction that's 2 sats per byte and gets confirmed within 1 block. We're gonna switch this one to 1. And we also have something, there's a third list. We have 3 lists here that kind of look like this. It's a list of histograms is the transaction confirmed stats, but we also have one for fail stats. But we have this other list called transaction count average. And this is just a single list, and it keeps track of the number of transactions that we're seeing for a fee rate range. And I said, yeah, if you got like a fee rate of 1.2 for a transaction, you would increment this bucket of 1. So this doesn't care about periods. It just cares about like when something was confirmed. And, well, it just confirms that, it cares that it was confirmed at all. I'm sorry, that's a better way to put it. And it tracks the fee rate of the transaction being confirmed. So now estimating a fee rate. When we want to know a fee rate for a given period, we want to get confirmed, like let's say it's the first period under 2 blocks. We use the transaction confirmed status to look through transactions of all buckets, going from the highest fee rate bucket to the lowest until we have a sufficient number of transactions. So if you tell me you want your transaction to get confirmed within 4 blocks, then I will choose period 2, and I will look at all the buckets from like the last one with the highest fee rate all the way to like the lowest that I can. And I will collect all the number of transactions through all those buckets until I have enough transactions. Then when I have a sufficient number of transactions, we'll check it against some success rate that's defined in the code. I forget what the success rate is for like the default fee rate computation, which is what we call like medium. And if the rate is high enough, we record the bucket and reset the count. If not, we keep going until it is. And we get the total number of transactions tracked for a passing bucket range and divide it. Okay, well this might be easier if I just look at the code. But usually it isn't. Estimate median val. So this is the code that is actually used to estimate the transaction fee. And it is as confusing as my description. But some things hopefully you could recognize, maybe. So the process that I was talking about before is this. When you call this method, you put in your confirmation target. So, which is gonna be like within 2 blocks. Or I would say like the first range, and the scale actually takes in like, oh, within 2 blocks. And scale is predefined somewhere else.
So is this like, I'm forming a transaction, and you pick if you want your transaction to be confirmed in 2 blocks or 6 blocks or
Yeah.
whatever. That's the target?
Yeah, that's what the conf target is, exactly. It's saying which range of blocks do you want your transaction like confirm within after entering the mempool. And then we have the period target. The period target is like, you know, the index of that array that represents the ranges. And you have like these concepts of current near bucket, best near bucket, and all these other things, which isn't super helpful again. And then the part where I was talking about where like you look within a period and you start from like this max fee bucket all the way to the least fee bucket, and you accumulate transactions until it is of a sufficient value. And when it is of a sufficient value, you check it against some success rate. And if it's below the success rate and it was passing before, then you like set these failure statistics. And otherwise, then like that bucket's good, right? Because it passed a certain threshold of success transactions. And then you'd set passing equals true and all these other things. And then you do this like thing where you get the median between like this best near bucket and this best far bucket. So like here we're trying to find like the best range of buckets for which when I say best, like the lowest fee rate buckets for which we have a sufficient number of transactions in that have been confirmed within our desired target range.
This block that's half off the screen, what is
Oh, okay. What is
is that a loop or 2 loops or what?
Oh, which one, or should I zoom out?
Scroll up a little bit.
Here?
Okay.
I can minimize this.
It's iterating over the buckets. It's from the top to the bottom, backwards.
Exactly, yeah. And then the best bucket is going to be like the last thing, bucket range that it recorded that had a sufficient number of transactions that passed like the success threshold.
So you want it to be lower.
Yeah, you want it to be the lowest fee rate possible.
Okay, so it starts checking for, this checks the highest first and doesn't stop until
until it looks through all of them, really. And then it says, hey, we looked through all the buckets and we've determined that like this is the lowest fee rate range, like, or the lowest fee rate that you could pay, and this is like where the maximum started when we started counting.
Is there like, how long does it keep those transactions in that list of periods?
Yeah, so that's like a harder question because there's this concept of decay that I kind of hate. Because you don't really remove things, like you instead erode the values of things using this decay value.
Interesting. So you still keep them in the list, you just, like when you're processing them, they just mean less to you?
Yeah. Certain things start to mean less whenever you start doing these certain types of updates.
Is decay a constant?
I know because you could have different transaction confirm stats. But for this scenario, it's easier to think of it like a constant. Because technically there's 3 transaction confirm stats. You have I'm just trying to find it. So you have a short, a medium, and a long transaction confirm stats. And you have 3 things that are crunching numbers in their own unique way. And I like to focus on the medium, because that's usually like what's used, but things like scale could be changed depending on which transaction confirm stats you're using. So the scale of the medium, I think, is actually 2. That's why I used 2.
Okay.
But yeah, just think of decay as like a constant. You know, it's the easiest way to conceptualize.
Or a configuration parameter that's basically constant.
Yeah, it's constant. Yeah, a configuration parameter that is constant for our explanation purposes. Then you have all these like failed bucket stuff, which also goes into some calculations. But the important thing you need to get from here is the fact that we're just looking for a fee bucket range that contains enough transactions to meet our like desires, and enough of those transactions should have been confirmed. Yeah. Let's see what else is here. And he has a whole bunch of comments, but these comments aren't very helpful. So, min bucket, max bucket. I'm trying to see where I was trying to show, and I don't even know. Min bucket, max bucket. So you have these transaction count averages. This is a good place to look at. Transaction count averages, I think I mentioned here, maybe. Yeah, so this is just a single list that keeps track of transactions within a given fee range, not caring about how long that transaction took to get into a block. So like this is just the total number of transactions that it saw at a certain fee range, or fee rate. And so now we have the transaction count average, and you do this computation. So you're saying from the bucket range that I look, for the fee rate bucket range that I'm looking at, that can get me within the confirmation target that I want to get all of the transactions that have like been confirmed previously. Or I'm like trying to think of a good way to explain it, but transaction sum represents the number of transactions that have been confirmed after X blocks of being in the mempool. And again, X is being used to track time for a given fee rate range. Yeah, does that kind of make sense? All of this is very hard to explain, and I know it's probably hard to keep track. I don't know why this code is so complicated, to be honest. But what you end up doing is you try and find like the average for that bucket range, and then you get this like fee rate average, which is a separate list that keeps track of averages for confirmations.
So just hypothetical.
Yeah.
If you had like somebody spamming the blockchain with a specific transaction two inputs, one output. Maybe the values change, but the weight of it is the same, right?
Yeah.
So say the whole blockchain, there's nobody making transactions except for this one. So all of those transactions would be in the same bucket, right? Because they're the same size.
And the same fee rate bucket for one of the lists. For transaction count average, it will be in the same bucket. Because this doesn't care about how long it took to confirm.
So how would that change the fee rate for the next transaction of the same type?
If it was added to the transaction count average,
I'm just trying to understand the dynamics of tracking these things.
oh, okay.
Like if you, just as a simple hypothetical, if you're like hammering like one particular bucket,
Yeah.
does that increase the fee for more the successive transactions of the same type?
Well, yeah,
The
so,
average would be like all the same. All of them would be like,
right, it would be this, exactly, it would kind of be the same thing.
so we wouldn't.
But also, well, some things you wouldn't be able to estimate. Or I guess like they'd be the same thing. Because remember, you have periods, and like when you ask Bitcoin Core for a fee rate, you say, "Hey, I want my transaction to confirm within 2 blocks." And then when you ask Bitcoin Core that, it says, "Okay, I'm going to look it up of other transactions that were confirmed within 2 blocks and try and get you a transaction fee rate that makes sense." So if all blocks were full of the same type of transaction, then like only that fee could be used because the Bitcoin Core doesn't know about anything else.
Everything would be whatever the fee that one is using. You'd be
Yeah.
competing with it. So if you wanted to increase the priority of your transaction over those, you would have to be
Just set your fee rate a little bit higher, you
a
know.
little bit higher.
Yeah. But we're at time. This is a shorter session. Maybe I'll look with you, you know, whenever we have time, and I'll look for a way to simplify this code or how to explain it.
Yeah, kind of like the thing that I would like to understand, I guess, would be like how different patterns of transactions coming in would impact the fee, and see why that works, and then and then look for why that works in the code.
Yeah. But first, I think this needs to be explained better.
Some of it is just like, I don't know, it seems like C++ programmers don't like having good variable names. So like, they have a million comments, but you could delete all the comments if you just had a nice long variable name.
This is true.
Yeah.
Or they assume a certain mental.
They assume you already know how the thing works.
Yeah. To be clear, I do not like this this code, but this is just what we have here in Bitcoin Core. Alex Marcos of Chain Code, you can complain to him. You know. And Ben Woosley also made some changes, which I saw his name on some of these comments.
I think the bucket term comes from histograms.
Yeah, honestly, if he used the word histogram, it would probably make things easier, right? I don't know if he
TXCT
implements.
average should
Huh?
like you should just kind of
Yeah, no.
transaction like DX okay fine, but just kind of call it count. I don't know.
Yeah, it would just be better. But all right, I'm gonna stop the stream. Thanks for coming. This was equally bad as it was the first time explaining fee rates. I think the problem is I can't explain. I'm not gonna say this is bad code. I can't explain unnecessarily complex code in an easy way if it's written in a way that's not fair. I'd have to refactor first and then explain it. Maybe that's what I'd do.
Don't people say like, oh, fee estimation is broken in Bitcoin Core?
It is anyway. So yeah, all this should be rewritten.
Is it because of this? Is it this specific code, or is it just an impossible thing to do right now with more like metadata?
No, it's this specific code that
Oh, okay.
people have been making issues about in the Bitcoin Core
Should we
repo.
just fix it? I don't know.
Isn't Peter Willie working on a whole
Yeah,
refactor of all of this?
Cluster mempool, no?
yeah, and on Delving Bitcoin, he has like posts. Yeah, there's cluster mempool, which I know Greg Sanders and Gloria Zhao were working on, but Peter Woolley has been posting all over Delving Bitcoin about this, or he has some thread, I think.
Master plan.
Yeah. But yeah, this is what it is, and I will end. I think I had a link to his discussion. Maybe I didn't. All right. Well, I'm just gonna end the stream so we can start bit devs. Thanks anyone who tuned in and watched. Thanks of course for coming early to take a look.